In Northampton, England, there's one landmark that's hard to miss.
The National Lift Tower was built in 1979 for research and development on lifts. It was opened by the Queen in 1982. It's 400 foot tall and is famous for being a continuous pour of concrete, so it's the tallest slip-form concrete building in Europe. Here at the National Lift Tower we test elevators, as you North Americans would call them, I guess, and we test various parts of the lift. The tower does move around a bit in the wind. Yeah, it moves probably about 2 inches off centre either way, and it is enough to sort of make you feel seasick.
The dizzying height isn't just ideal for testing elevators. Welcome to the draining job of Stephen White, an engineer with Studor Limited.
This building represents a 40-storey building, so it's the highest facility in the world that we can actually test on.
They've rigged 10 toilets up the stairwell for the biggest drainage test ever done.
So we're going to put in sanitary towels, tampons, toilet paper, wet wipes, solids as well. We've got sausages that we're using to represent human waste, dog food, cat litter, earbugs, you name it, we're going to flush it in there.
He's doing this because 100-year-old building codes are failing in more and more modern high-rises.
Because everyone thinks that your waste flows downhill. In reality, with the drainage system, is 20% solids and liquid, 80% air.
When all that air and waste hit the ground floor, the waste goes to the sewer, but the air needs to travel somewhere. Big problems arise when that air isn't vented properly.
What we're finding now is that a lot of the venting is undersized, and that leads to problems with exploding toilets. If you stay in the hotels, often you can hear the floor drains and you hear this banging. When you're hearing gurgling, or you hear the bubbles, or you see the toilets moving up and down, urinals splashing out with the wet floors, that's your drainage venting failing.
When air pushing down is blocked by too much waste in the pipe, it has nowhere to go but up.
So if you hit the base of the stack and you have a water curtain, it's a fast reaction time of the positive pressure, and that reflects back up the drainage system at 320 meters a second, or the speed of sound. So it's an acoustic event.
And the only protection from that sonic boom is 5 centimeters of water.
Now, if that barrier is lost, then all the smells and possible viruses that are in the drainage system can come into the living space.
That's especially true in crowded buildings at busy times of the day. Here, they can study how one flush can interrupt another, causing the system to back up. Enter an ingenious solution, the Studor valve.
What we're doing is balancing the pressures there, so the valves will open and puff a little bit of air in there just to reduce the pressure regime. We're keeping it very, very smooth.
It works between higher floors, but can't cope with pressures at ground zero.
We're at the base of the building where the stack's dropping 124 meters and it's turning direction before it drops off and goes into the main sewer. So this is the major point that we get problems with drainage, because as the water's falling about 3 meters a second, it changes direction.
Okay, we're going to do a toilet paper flush.
Flush it. You can see the toilet paper coming in here, obliterates itself, and then we've got the flow coming in afterwards from the flush.
Tampons and wet wipes cause even bigger problems.
If you listen to it, the towel just went off there, and you can hear it hitting there, oscillating, and that's the second towel coming in there.
If these towels block the air traveling down for just 10 milliseconds, it blasts back up the stack at 320 meters a second. To prevent this, Studor invented the positive air pressure attenuator, or Papa. It's an industry game changer.
Traditionally, we use these vent pipes here, and as you can see, in the UK and Europe, the vent piping is actually smaller than the waste carrying pipe. So this is why we've developed the Papa system to eliminate this pipe work, so we can keep to a single stack.
It's a simple idea that uses 3 million data points and took 3 years of research to perfect.
As you can see, the slight movement, it's basically like a lung. From the negative pressure it's closing, positive pressure opening, and just by opening the bag, we get the attenuation and slow the speed down from 320 meters a second to 12 meters a second.
In other words, it prevents exploding toilets. To show us what they mean, they turn the Papa system off.
Drainage it protects health. It has been from the cholera outbreak in London in the 1800s. This is where we have modern drainage with Victorian sewers. So if we take the SARS outbreak in our Moor Gardens, there were 56 fatalities, and the actual virus moved up the drainage system. So there's a World Health Organization report that actually showed the spread of the virus actually moved up the building.
You ready, Tony?
And that's why Stephen and his team will continue to prove their technology in the world's tallest test facility.